I am just the moon and I'm reflecting the light of the sun when I make this presentation because we have, very big shots, including VK Paul sir from SPA New Delhi and Professor Devan, who lets an ordinary PhD scholar like me to make presentations in such important forums. So thank you to my professors, and thank you to Dr. Amar Ali Khan and Yogita for giving me this opportunity. So I would just start my presentation. In any case, if there's some issue, you let me know. So is my screen visible?
So your screen is visible.
Okay. So my topic that was allotted to me was performance-based versus prescriptive norms. And I am Raja Singh, as very nicely introduced by Yogita ma'am. And I am guided by Professor Dr. Anil Diwan, who's a patron for all the work that I do. And just one second. Yes. The hypothesis of this presentation I'm making is that we are building structures, especially iconic structures, where the concept of compartmentalization is getting diluted. In such a scenario, the prescriptive codes designed with compartmentalization as their basis must be replaced or complemented by performance-based fire codes. And we are seeing the slow demise of compartmentalization, and I will show you how. So I also want to ask you a question. Should all buildings, especially iconic buildings and naturally ventilated buildings, also I'll tell you why naturally ventilated buildings, be declared guilty until proven innocent with respect to fire spread? So I want to ask you one common question. Now the concept of offices has changed. Earlier, it used to be room, 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 closed room, and there was compartmentalization even in, the way teachers used to be sitting in corridors. But today, the concept is of open plan. We have huge floor plates which are open plan, and there is no compartmentalization. Not only that, there is vertical non-compartmentalization in buildings, which I'm going to show you. For example, if we look at an iconic structure on the left, which is the Rashtrapati Bhavan, where the way older iconic structures used to be, compared this to Burj Khalifa. Now, what the comparison is that in one, compartmentalization has been key, while in Burj Khalifa, there is a shell structure. It's not typically a shell, but it is uh, in the inside, there is a continuum with respect to the vertical space. And this is how it is. This is the atrium area of the Burj Khalifa on the right. And on the left, you can see how finely divided is the compartmentalized older iconic structures that we have been dealing with, and the basis of which has been the formation of our prescriptive based fire codes in across the world and also in India. Now, I went to, like in 2019, the Kartarpur corridor, Indian side, made by Creative Group. And what I realized that this is such a huge space, like an airport terminal. And over there, it was, like there were sprinklers that had to be put based on a prescription that is made, because sprinklers have to be put in such structures based on prescription based code. But I want to figure out that what is going to happen when fire happens in such a structure which challenges the way compartmentalization has led to creation of prescription based codes. So I will we'll see through simulations how what I'm saying makes sense. So very small example, left side is compartmentalized structure, on the right side same atrium, non compartmentalized. Somebody on the bottom ground floor, there is a fire and the smoke is seen on the top floor. This is very common. This is, as sir was also talking that, oh, it was a building where the windows could not be opened and smoke could not be taken out. Now, that is very much the case when there is no shaft compartmentalization and vertical continuum exists. But we want such buildings for other important things of continuity, of beauty, of aesthetics, and so many other things. So we cannot simply say no to such structures, but we have to take care of the fire issues in them. Now, what is the traditionally we have been dealing with prescription based codes, which are beforehand instructions, and the compliance of which the buildings may remain safe. There has been cases where prescription based safety in the buildings, these buildings which are prescription based, have ill performed. Our take is that fire performance of naturally ventilated buildings needs to go through the scrutiny of performance based analysis. And this system has been developed earlier through zone models like CFAST models, and finally to field-based models which also use CFD technology. Now, this can be read as I talk further. One second. Yes, let's see some simulations before I move forward. Can you see the screen, Yogita? Yes, naturally ventilated building typology, chimney type structure. Very common. This is from a very famous hotel in Chandigarh, uh, Marriott Hotel. This is how they are. On one side, they have created a chimney type structure. On the other side, there is a restaurant. And you can see the various cases which we have dealt with in this building have been like this. In the first case is the default case. If the fire is at the ground floor and there is, even there is an opening or an exhaust at the top in the chimney or the shaft area, there is still smoke and high temperatures in the upper areas. You can see black over here represents smoke. There is a built-up of smoke in the upper floors, very much there. Before going forward, I want to thank my supervisor, Tadepalli Srinivas of NIT Trichy, under whom I did this project in my master's at NIT Trichy. So thank you. He may not be here right now as part of our audience, but I want to thank him because he promoted me a lot in this area. Now, same case, if we put a outlet at the ceiling, there is no outlet at the ceiling, I'm sorry, then what happens? So you see, this is all blue, which means lower temperature and less smoke. Where what happens? There is a higher smoke. And sometimes I have seen in buildings, you must have noticed in buildings, they just simply cover the atrium as retrofit for air conditioning and they don't give requisite exhaust of the smoke. A consequence of which is, as sir was saying, no, the building becomes air conditioned and the smoke spread is distributed to other habitable areas where there will be people in the same space. So you can see a very easy representation of the same smoke spread. Same again, fire break at the first and second floor. If you simply use compartmentalization in these spaces, you see absolutely no smoke in the floor 1 and floor 2. So this compartmentalization always works, but for other factors, we are compromising compartmentalization, which is maybe that is an important thing, but we have to, if we don't have compartmentalization, at least we have to check buildings with non-compartmentalization against performance-based codes. So again, atrium type building, very common. You can see on the right side, there is this building which is which is having atrium. Top is covered, which we must notice. All major buildings today are like this, with a center space and atrium on the top. And some of them put those nice rota vents, some of them don't. Some of them depend upon a system which might fail during a fire, which has a suction-based system. So we have to have redundant systems which work even if the system fails during a fire, even if the exhaust fails during the fire. And we will see what happens. See, in this case is the default case, fire in the ground floor. You can see there is a outflow in the second floor, hot gas is there. There is smoke on the second floor as well. And this is the normal default case. What happens if we just close the atrium totally? The maximum flow increases and the temperature, see from blue it becomes green. The temperature is increased in this atrium zone and there is a slight increase in the outflow at the second floor. So innocent people in the second floor bear the consequences of what is happening in the ground floor in continuum spaces, which we are trying to regulate only by prescriptive codes without actually seeing the smoke performance. So this is very important to have this included in our system, in our way we deal with buildings. Now, same building, what we did is we substantially increased the ceiling opening by half open to sky. Here you see the opposite happens suddenly. There is so much exhaust from the atrium that there is an inflow from the first floor and second floor. Amazing case of, having just a tweak in the in the small design decision, based on performance, based on simulation, so that this building can be saved in case of a fire situation. See, there is very little smoke and there is the zone with no smoke is there in the bottom where people can crawl and keep themselves safe. They can lie down on the floor. So this is that limit in which people can be, made to be safe. Now here again, atrium with mechanical exhaust. Same result as making half of the atrium open. Everybody will agree, oh, mechanical exhaust, we already know. Fire people know. Fire engineers know. But what happens when this system fails? In that case, we need to have redundant systems which are openable also available in such buildings. And the basis of what I'm trying to tell is that for such buildings, there should be an absolute requirement to make sure they go through a performance-based check. You know, so let's go ahead with natural uh, building or the shaft type, as we have discussed earlier. Now, shaft type is like there are two shafts. This can be a, not a properly designed staircase shaft. This can be a normal shaft which has been made for uh, thermal passive heating, passive cooling purposes also. Here you can see floor, there is fire at the bottom, and in the default case, the smoke automatically goes into the topmost floor. You can see if there is no outlet at the shaft ceiling, same performance, so much deep smoke on the second floor is visible. But here, if we open the ceiling or shaft open to sky, fully we make it like that, you see absolutely no smoke in the ground, in the first and the second floor, all the smoke directly exits. Now, what I'm trying to show through this thing everybody will say this is common sense, but common sense is uncommon. So that is not being implemented in many of the buildings today. Same in the single-sided ventilation systems also, it's compartmentalized, no problem, no sharing of vertical circulation, so no problem at all. Cross ventilation, here we have taken an example of if there is cross ventilation and that the fire door, as somebody was saying, auto closing was not working. So we have shown if auto closing was working and the doors are isolated, it just isolate. Perfect example of compartmentalization. Same fire, in this case, it was compartmentalized and it does not spread. So this is the result. I can share it is available in a paper published by Time, Space and People. The point is references. The point here is that as the NBC has recognized, if you read this part of NBC, point P says, if so required by the authority, an engineering analysis should be performed which demonstrates that the smoke system for the atrium is designed to keep the smoke layer interface 1800 above the highest occupied floor level of exit access open to atrium for a period equal to 1.5 times the calculated egress time or more for 20 minutes, whichever is greater. There is a provision already in NVC, but that's the only place where such provision has been made. We should, as a voluntary effort on the architect side, because now we have access to simulation systems, because for the green building, we are already doing simulations. We should also make our buildings go through this. And so the point is the next step that we have to go is performance-based systems which use simulations. Of course, there are limitations. Simulations are not perfect. Some architects may have issues in getting access to such software and such experts who do it. It may be expensive. But such provisions have been made in the green building industry. Eco Samhita is been made very easily available for ventilation and other stuff. Efforts should be made for fire as well. Conclude. Yes, absolutely, sir. Only the last slide. Now, this is about performance based is over. Last slide. Another issue is implementation of fire extinguisher devices for residential areas and building not require fire energy, covered extensively by respected Paul sir. 10 of the 16 major fires since 2015 in Delhi were of residential buildings. This is a Hindustan Times report. We should have some kind of a self-certification based checklist, which just like the shop and establishment certificate should hang as soon as you enter a mixed use type establishment, so that it creates a deterrent on the part of the owner that he has to maintain it. And on a random check, if he is found not following it, this should create some kind of a scare like a traffic challan. Thank you so much for giving me an opportunity. I thank Professor Devan for giving me this opportunity. And I would now request, thank you, sir, for giving me the time. Thank you.